Hello, my name is Rob Reynolds. Welcome to College Algebra Section 4.1. Today we're going to be looking at linear functions, and they graph lines. And the general form of a linear function is y equals mx plus b. We're going to be using the m as the slope and the b as the y-intercept, and sometimes I call that y-intercept a start value because that's where we're going to start. After we start at a point, then we do our rise over run. Two definitions for slope. If I give you a graph, you're going to use the definition of rise over run. If I give you 2 points, you're going to use a different definition. It's still rise, it's the change in y, which is the rise, over the change of x. Sometimes it's denoted delta y over delta x. So two definitions for slope that you should know. So again, y equals mx plus b, where b is the y-intercept. It's a start value. So in this particular case, I'm going to start at 7, which is off my graph just a little bit. But the slope is negative 3 over 1, which means go down 3 and right 1. Down 3 because the 3 is negative, right to the 1 because the 1 is positive. And we usually stick the negative in the numerator. It's seldom that you will ever see 3 over negative 1. If you see that, sometimes they throw the negative out front, but I would prefer the negative in the numerator, so I'm going to count down 3 over 1, down 3 over 1. Repeat this process until you fill up your graph, and then you have a nice straight line that you can draw in with constant slope. And there's the author's answer. Here's 2 points. Average rate of change is a fancy way of saying slope. So the average slope between 2 points, you would just do, again, y minus y over x minus x, because I gave you 2 points. To find the change in y distance is 200. Change in x distance is 15, and you would reduce that slope. If you get a decimal answer, just hit math, enter, enter, and that'll convert your decimals into a fraction. So I would say the slope is rise 40, run 3. Change in y over change in x, you can see it's constant slope, so you're checking for constant slope here. The change in y looks to be constantly 3, and the change in x's looks to be increasing by 1. So as long as the x's continue to increase by 1 and the y's continue to decrease by 3, the slope is negative 3. Here's a couple examples for you. Number 16, I'll graph here. This says start at 6 and go down 1 over 1 and continue down 1 over 1. Number 17 says start at negative 3, it's a start value, and the slope is rise 1 and run 4. And the last one is y equals line, and it's just a horizontal line, y equals negative 2. Remember, if it said x equals negative 2, that would be a vertical line, and that would say all the values, every point on here, x would always equal negative 2, and then there'd be some y value. But no matter what, x would always equal negative 2, and that's why we call it x equals negative 2. Be careful, the slope of this line is no slope or undefined slope. The slope of this line is 0, so horizontal lines have 0 slope. You can write the letter Z, Z-E-R-O. Horizontal lines kind of set on the horizon, they have 0 slope. So here are some answers to functions. Again, average rate of change is nothing more than just the slope definition. We could do f of b minus f of a all over b minus a. It does not matter. This is the calculus definition that they use for average rate of change. But usually it's the second point minus the first point. It doesn't have to be. You could do the first point minus the second. Just be consistent. This says plot the ordered pairs and then use the average rate of change to determine whether the functions are linear or not. The easiest way to plot these ordered pairs is to go to your calculators. I'll show you how to go under statistics, stat, and enter. Under my list 1, if you have numbers under there, you can highlight list 1 and clear. I'm going to use my x values, 0, 1, 2, 3, 4, 5. I'll go to the list 2. Takes just a minute to type these in. I'm so sorry, I'm really slow using the mouse here. Alright, but at least you can back up the video if you didn't catch this. I'm going to hit stat. Let's see, really I'm just supposed to do a scatter plot. I'm not supposed to find the line of best fit here, so I'm going to change my mind. I'm not going to hit stat. I'm going to hit, most of us can just go to our y equals. I'll clear out any function that's in there. I'm going to highlight your plot 1 and press enter and hit zoom 9. That should give me a scatter plot. If it doesn't give you a scatter plot, hit second y equals, go in and press enter and just make sure that you're highlighting the scatter plot. Some of you might have box and whiskers, but this is what you've activated when you hit your y equals and you turn on your plot. That's what it's doing. So again, zoom 9 is a statistical plot. It'll set your window, so it will be a good stat plot. Later in this chapter, we're going to be finding the line of best fit. But your calculator just plotted a bunch of points for you. Again, we can find constant slope. And let's see, now it says determine whether the function is linear or not. So again, to determine whether it's linear, we're going to look for constant difference in change in x and change in y. And on the calculator, it does look linear. Maybe it's quadratic, but I think I could get a best fitting line out of this. Oh, and they changed the function. Well, yeah, great. So I could do this again. Go back to stat, enter. I'll edit my list. Didn't even realize they gave me new x and y values. Hopefully on this problem they'll actually ask us to find the best fitting line. If they don't, I'll go through that with you as well, because that's in this chapter, and I might as well, since I'm spending the time to type this in, I might as well go ahead and show you not only how to statistically plot all of these points, but to find the equation that best fits the linear function. And then later in this chapter we're going to be doing quadratic regressions, plotting points. Alright, 37, let's see if I think I got that right. So it says determine whether the function, again I'll hit zoom 9. I've already activated my plotter, so zoom 9 should give me a, oh, that's definitely linear. So I would say yes. Do they ask for the, is it linear? Yeah, you can check the change in y, change in x. Do they even ask? No. So let me just walk through, because this is a skill you're going to need. So to find the equation that best fits this line, hit stat, arrow right, calculate. 4 is linear regression, and I'm going to go to vars, y vars, arrow to the right. I'll press 1 for function, y sub 1. So what this is going to do is not only find the linear function, but it's going to dump it under your y sub 1. If I press enter, it'll give me the equation, and notice if you go to your y equals, it'll also have dumped that whole equation under here. So now when I hit zoom 9, not only does it give me the points, but it'll actually draw the line that best fits. If you want to see some estimations, you hit your arrow down and you can scroll along the line and make some predictions either in the future or in between points as well. So if I hit trace 55, which was not actually a statistical, whoops, hit trace arrow down to get on the line, 55, you can see this is not actually a point that was on the function, but I can make predictions. If x was 55, it's around 41.25, and that's pretty close for in line with what you see here. So again, the goal here is just to check out to see if these are constant x changes, and if so, are they constant y changes? So you're just telling whether these are linear or not. Let's see, this looks like it's decreasing by 3. It continues to decrease by 3. 1 minus 3, minus 3, minus 3, so that looks linear. So you're going to look, and that's the purpose of all of those. Functions that are increase or decrease, we need to find the max and the min, and then it's going to be increasing to a certain point and decreasing. Usually we talk about the intervals of increase and decrease. So once you find that max and the min, if this is the minimum, we would say this thing is decreasing from negative infinity, are those x values, so from negative infinity all the way up to that x point, let's call this point 7, negative 3, just making this problem up. So this thing is decreasing in yellow, which I didn't draw very well. So in this yellow section, it's decreasing from, so I would say this particular function decreasing from negative infinity all the way up to the x value 7, and it's not decreasing at 7, so I'll put a parenthesis there. And it looks like it's increasing here in this blue section, and so I'll say, well, I'm starting at 7 and going to positive infinity. So it's important to find the max and the min to find out, oh, this is even easier, because if the slope is positive, then it's increasing. If the slope is negative, it's decreasing. Positive, increasing, and remember this is horizontal, so we would say constant slope. So all you have to do is, if the slope is positive, it's increasing. That's even easier than what I thought it was going to be. Some applications to these problems. They look difficult, but there's a lot of words, but it's really not that bad. We're probably going to be writing equations of lines. Y equals mx plus b. Looks like they're giving me the slope is 4,000. That's the change. And probably the start value is 28,000. And what are they going to ask for? Express the value of the book of the car in terms of x. There you go. There's the value of the car in terms of x. So after no years, 0, if that was a 0, the car's worth 20,000. Oh, it depreciates, so it's probably a negative in here. So after 1 year, it's going to be 20,000 minus 4,000. After 2 years, it's 20,000 minus 8,000. So again, you can see it's a linear function. Well, that's a 28,000. How come I didn't catch that? This is a 28,000. Sloppy handwriting. So it's 28,000 minus 8,000 would be, well, it's worth 20,000 after 2 years. And so you could graph this. So after 3 years, all you have to do is plug it into that formula that we had. But remember, every year it depreciates by, what was it, 4,000? Yeah. So after 3 years it depreciates 12,000. So all you have to do is take 28,000 minus 12,000, or you could just plug it into the formula that you had. You could also do this on your calculator. You could type this in and hit trace 3, enter. You might have to change your window for that to happen, but that's the easiest way to evaluate functions. For this particular problem, we're going to be looking at when the supply equals the demand. This is the equilibrium point, or the point of intersection. So really, you could just set these two functions equal to each other. So I could say 60p minus 900 is equal to, maybe this is the easiest way, but I'd like to show you how to do it on the calculator as well. 2850. And then you could just solve for this, and you'll get p equals 50, and all you need to do is plug that p equals 50 in here and solve for either s or d, and I believe that'll turn out to be around 2100. So again, I wanted to show you a different way. This is just when do the 2 points intersect each other, and that happens when the x value is the intersection at $50. But if you wanted to look at this on the graphing calculators, we could graph this on the calculator as well. So getting a feel for this, it's saying, once again, that when is this function going to be greater than this function, and that happens at that break-even point at 50 again. So the company is going to charge more than $50 than the quantity of the supply will exceed the quantity. This will make more sense once we kind of look at the graph of this. So I like to go to the graphing calculators and actually just see if we can't get a good feel of what these functions look like. I'm going to turn off my plotter so that doesn't interfere with my graphs very well. So I'm going to highlight plot 1. My calculator will cooperate. And press enter. That'll deactivate that plotter. So it's not going to be trying to do statistics as well. So I'm going to type in 60x, even though it says p, minus 900. I know the y-intercept is 900, so I might have to change my window. But this is worth it because this will frustrate some of you about how to guess what your window is. So I wanted to show you how to set. I always hit zoom 6 the first time I graph, but again, I'm not going to be surprised if I don't see anything because I got a y-intercept of negative 900 and another y-intercept of 2000. So I'm going to hit zoom 0. Sometimes zoom 0 will find the function, sometimes it won't. I might have to play around a little bit more. It looks like I got to see further to the right. At least I found the functions. So I'm going to go to my x max, and I'm going to look much, much further to the right, like maybe even 100 units off to the right. And then if I need to see further up and down, I can. Yeah, that's pretty good though. So let's go find that point of intersection by doing second calculate the intersect, which is 5, and I'm going to guess on the first curve, which is the y-intercept of 900, the second curve, which is the y-intercept of 2850, and then I'm going to guess the point of intersection. So the first two enters was just identifying the two functions. The third time I press enter, it actually gives me the point of intersection. So that's what they want you to calculate on the calculator. Again, it might be easier to do that just simply by hand because we had the solution quite a while ago solving it. But the 2100 is the dollar value that breaks even. So this is kind of interesting. It's saying where are the two functions equal, and the two functions are equal when I let x equal negative 4. The second part says when does the blue f at x function, when is this greater than the pink function? So it looks like the blue function's greater for all of these star values. So I'd probably say something like, oh, the x values are from negative infinity. This is going to be greater from negative infinity off to the left. I don't care about high and low because if I'm talking about when the function is greater or less, I'm talking about x values, all the way up to the x value of negative 4, and I probably wouldn't include that. So there's a couple other practice problems. There you go, negative to negative 4, those are solutions. This is kind of interesting. Where are the two functions equal? When does f equal g? Whoosh. So let's let the f function be yellow, and the yellow will equal the g function, looks like at x equals 7. And the last one is the h. When is the green function above the yellow, which is above the pink? When is the green above the green is above the yellow here, which is above the, so maybe in these smiley faces, the green is above the yellow, which is above the pink, only in this area where it's the happy faces. So I'd probably say that between negative 4 and the x values. I'm just going from the x value here to the x value here. So it looks like from negative 4 up to 7. Yeah, I guess I could include, because this was an equal sign, so this is no longer parentheses, this is a bracket if it equals that. So those are some interesting problems that you might get. This was another linear function. Here you're going to let x be 40 and evaluate the cost. This says if 80 is the cost, solve for x. So that's part B. And then part C is the maximum number of miles that you could drive. And that this is going to be less than 100, and you solve. So that'll finish up section 4.1. If you have questions, feel free to email me.